Hello everyone. My name is Anam Ahmad and I'm a researcher at the University of Melbourne. Today I will be talking about how gaze and speech can be effectively combined for enabling implicit interactions. Multimodal interaction refer to those that utilize multiple modalities to exchange information. One such potent interaction is produced when gaze and speech are combined. Most gaze and speech interaction techniques use data from these modalities as explicit input, where speech is used to communicate user's intent, while the gaze is used to disambiguate the target of a speech command by requiring the user to direct their eyes as pointer. Even though the resultant interactions are robust, users are likely to deviate from their natural behavior. This is because users are more likely to simplify their speech command, while the use of gaze as a direct input requires conscious user's effort that can induce an undesirable cognitive workload. Thus, to enable true natural multimodal interaction, we need methods for integrating these modalities. Therefore, we explore how natural gaze and speech could be integrated for enabling implicit interaction. We demonstrate our approach in the challenge of anchoring voice note, which relates to the problem of mapping a voice note to the digital region to which it refers. Our prior work attempted to solve the challenge of anchoring voice notes by leveraging users' natural gaze pattern. Our work highlighted that the gaze-based approach does not work for some specific scenario, such as whenever user depicts similar gaze pattern in two adjacent text region. We argue that a multimodal approach combining the content of user utterances and their gaze behavior can better overcome the challenge of anchoring voice note. This is because of two reasons. First, while uttering notes, users often tend to comment about the content they are reading. Hence, the note content can have relevance to the text regarding which a note is made. Second, while uttering voice notes, users often directly look at their focus of interest. Hence, the speech often include terms which explicitly refer to the items of interest. Therefore, we performed a combined analysis of users' natural gaze and speech behavior and present a machine learning based pipeline that built a prediction model which indicates the relevant region for anchoring nodes. For this purpose, we employed a previously collected data set that contains gaze and speech of users while reading and recording notes. The input to the machine learning pipeline was the voice note, which has to be anchored, the candidate text passage that the participant had read during note taking, and the gaze data depicted by the participant. The input was first used to engineer lexical features. For this purpose, we first obtained the textual content of the voice note. The candidate text passage and the transcribed note were then fed into a sentence bird model, which represents semantically similar sentences by similar vector. We then use these vector embeddings to find the cosine similarity between the transcribed note and the text passage. The obtained scores were then sorted to obtain the semantic rank of each text passage. Our exploratory data analysis revealed that there were some notes that reflected participants' own opinion, and as such, their content is likely to be unrelated to the text passage. Therefore, the relevance rank calculated for the text passage of these notes would not be useful and should not influence the classification pipeline. To identify the pattern of such notes, we calculated a p-value for the semantic relevance rank of each text passage. This was done by first randomly selecting 100 text passages which were unrelated to the document being read by the participants. We then found the cosine scores between the unrelated text passage and the voice note to create a sampling distribution of cosine scores. After building the distribution of similarity scores, we obtained the p-value feature for the observed cosine scores of text passages. Our expertise analysis suggests that users often made voice note in which implicit references were made to data displayed on the screen. Therefore, to capture these patterns, we focused on jointly analyzing data from both input modalities to engineer features that can identify users' visual attention while making implicit reference to content. For this, we analyzed each note content to observe whether demonstrative pronouns were occurred in it. Whenever a note contained these pronouns, we expected that an implicit reference to the content displayed on the screen would be made. Hence, for each voice note, we analyzed the gaze during a specific window and engineered gaze features which reflected which textual content users looked while uttering an implicit reference. Lastly, we extracted reading pattern-based feature that captures user global gaze behavior while composing voice note. For this, we leverage our previously proposed annotation classifier to obtain the probability for the candidate text passage being predicted as annotated based on users' global gaze pattern while they read and recorded voice notes. After engineering various features, we combined them in a logistic regression classifier that could predict referent text passage for anchoring voice notes. Our findings show that the proposed multimodal approach, combining users' gaze and speech, outperformed the unimodal approach by an average precision of 12%. This is because our pipeline leverages data from both gaze and speech modality, which capture a different dimensions of users' input. Speech capture what the user is speaking, and gaze debate the global reading pattern of the users while reading. Additionally, the leverage synchronicity between gaze and speech input captures the user's visual attention while implicit reference were uttered. Thus, when data from both modalities are combined, they complemented each other and are more informative for anchoring voice note. Overall, our work contributes a machine learning pipeline for implicitly annotating voice note by combining users' natural gaze activity, the semantic knowledge from their vocal utterances, and the synchronicity between gaze and speech input. To such a pipeline, our work enables design of multimodal system that combine natural gaze and speech pattern to enable novel natural user experiences. That's all from my side. Thank you for paying attention.